Yes, welcome to you all. This is Alinder Day. Today I am going to explain the basic concept of stress and strain. So first, this is stress. The basic thing of stress is it can be said like this: the resisting force per unit area of the surface is known as the simple stress, or you can say the intensity of stress. Now we will see what is stress. Stress means when you are applying force on a particular object. So there is a surface. So the stress is basically the force divided by the area. You can denote it like stress is equal to force divided by area. The notation of the stress is sigma. Sigma is equal to F divided by A. F is the force which is applied and A is the area. So this area is basically the cross section area on which the force will be applied. That is the main thing. And one more thing, that stress is basically divided in two parts. One is normal stress and another is shear stress. The main thing of normal stress is it acts perpendicular to the area, and the shear stress is acts parallel to the area. Normal stress, which is denoted by sigma, and the shear stress, which is denoted by tau. So in this figure you can easily understand that this is the cross section of one object, and you can you know that there are three planes, x, y and z. So among these three planes, only the plane x, this plane is perpendicular to the surface, and plane y and plane z, these two are both are parallel to the surface. So we know the perpendicular to the area means that is the normal stress. So the force acting in the direction of x, that will be the normal stress. So in this equation you can easily see that sigma x is equal to delta fx. Delta fx is the force acting in the direction of x divided by delta a. Delta a means this area, cross sectional area. So in this figure there is only one plane which is perpendicular to the area. So corresponding there is only one stress which is perpendicular to the area. As we know, there are y and z, two planes are there which are parallel to the area. So tau y and tau z, two shear stresses are there which is calculated, or you can easily find out by delta fy by delta a and delta fz by delta a. So this is the basic concept of stress, and now we are going to explain the strain. The strain, we can easily denote the strain, we can easily explain the strain like this. The elongation per unit length of a body is known as a longitudinal strain or the simple strain. So it is denoted by a Greek symbol, that is epsilon. Now when you are pulling a object, pulling or pushing, whatever it is, the object will elongate from its previous or original length. So suppose L0 in this figure, L0 is the original length of this figure, and after applying force the length is converted to small l. So there is some difference in the length, that is L minus L0. So we can explain the strain with deformation divided by original area. Deformation means you can say delta L divided by L0. As we know, L0 is the original length of the object, and the deformation means delta L. We can simplify this delta L by small l minus L0. Small l is the length after applying force, and L0 is the length in the original or previous condition. So finally epsilon is equal to L minus L0 divided by L0. So when there is a tensile force which is applied to the object, then the elongation will happen, and the epsilon or simple strain will be denoted in plus sign, that means it is a positive strain. But when compressive force will act in the different direction, then there will be the shortening of the object. So the delta D and D0 divided by D0, that will be the epsilon D. So you can see in the figure that the small d0 is converted to D, so that is a shortening of this object in this direction, so it is a negative strain. So now another type of strain is available, that is the, you can say, the shear strain. Shear strain means when a rectangular element of a body is distorted by shear stress, it is known as shear strain. This angle, you can see, this angle is defined as phi, and the shear strain is defined as the change in the right angle of the element measured in radians, and it is obviously dimensionless. Now there are some basic things we can see. Engineering stress. Stress, we know one is tensile stress and another is shear stress. Tensile strain means the force are provided in the tensile direction, or it may be exactly opposite direction, so it is denoted by sigma, and in shear stress it is denoted by tau when the force are applied in the parallel direction of the force. Similarly, strain, there are basically three types of strain. One is tensile strain, one is lateral strain, and another one is shear strain. Tensile strain, we know delta change in the length divided by original length. Lateral strain means change in the length, change in the width actually, that is W0 divided by the original length W0. Okay, and another one, last one is a shear strain. Shear strain is basically the same as I told earlier, that it is measured in radians, and all the strain are dimensionless. And finally, the figure we can find out the stress strain diagram will be like this. In this direction it will be strain, and this direction it will be stress. Another diagram we can see, this y-axis consists of stress and x-axis consists of strain. Now this is the curvature of the stress strain. This is the stress strain curve. So up to this point, from here to here, it is a straight line, because we know it follows the Hooke's law. The stress is proportional to strain up to this range, up to this area. So after that there is some depression of the curve, and again it is rising up to a point. So this previous point, this is the yield stress point. The corresponding stress is called yield stress, and corresponding strain is called yield strain. And this point, it is the maximum force or maximum stress one object can take. So this corresponding stress is called ultimate stress, and this corresponding strain is called ultimate strain. And after that, after this position, if you increase the stress, then there will be the break point of the object. That means there will be the failure of the object occur. So this is all about the basic concept of stress and strain. Thank you.